Welcome to our lesson on IUPAC nomenclature for haloarenes. In organic chemistry, being able to name compounds according to IUPAC rules is a fundamental skill. Today, we'll focus specifically on haloarenes. Let's start by defining what haloarenes are. Haloarenes are aromatic compounds in which one or more hydrogen atoms of the aromatic ring have been replaced by halogen atoms such as fluorine, chlorine, bromine, or iodine. Now, let's discuss the IUPAC naming principles for haloarenes. When naming haloarenes, we follow these key rules. 1. We use the parent name benzene as the base. 2. Halogens are treated as substituents and named accordingly: fluoro, chloro, bromo, or iodo. 3. If there are multiple substituents, we use the numbering system to indicate positions. 4. The lowest possible numbers are assigned to the substituents. Let's start with a simple example: chlorobenzene. Here we have a benzene ring with one chlorine atom attached. Since there's only one substituent, we don't need a position number. We simply name it chlorobenzene, combining the prefix chloro for the chlorine substituent with the parent name benzene. Now, let's look at a more complex example with multiple substituents. Here we have 1,3-dibromobenzene. In this molecule, we have two bromine atoms attached to the benzene ring at positions 1 and 3. To name it correctly, we 1. Identify the parent structure as benzene 2. Count the number of bromine atoms 2, so we use the prefix D3. Specify the positions as 1 and 3, 4. Combine these elements to get 1,3-dibromobenzene. Let's examine a more complex example with different types of substituents. Here we have 1-bromo-4-chlorobenzene, which has a bromine at position 1 and a chlorine at position 4. When we have different halogens on the benzene ring, we list them in alphabetical order. Bromo comes before chloro alphabetically. However, the numbering should still give the lowest possible combination of numbers. We number the ring so that the substituents get positions 1 and 4 rather than, say, 2 and 5. Let's look at one more complex example. This is 1,2,4-tribromobenzene. Here we have 3 bromine atoms at positions 1, 2, and 4. We name it as try to indicate 3 bromine atoms. Bromo for the bromine substituents, positions 1, 2 for to show where they're attached. Benzene as the parent structure when assigning position numbers. We choose the arrangement that gives us the lowest set of numbers. For example, we use 1, 2 for rather than 1, 3, 6, or 2 for 5. Finally, let's briefly mention some common haloarenes and their practical applications. Chlorobenzene is used as a solvent and in the production of pesticides. Bromobenzene is used in organic synthesis as a building block for more complex molecules. DDT, dichlorodiphenyltrichloroethane, contains haloarene structures and was once widely used as an insecticide. Understanding IUPAC naming of haloarenes is crucial for clear communication in chemistry and for understanding the properties and reactions of these important compounds. In conclusion, IUPAC naming of haloarenes follows these key principles. 1. Use benzene as the parent name 2. Name halogens as substituents: fluoro, chloro, bromo, iodo. 3. For multiple substituents, use prefixes di, tri, tetra, and position numbers 4. List different substituents in alphabetical order 5. Choose the numbering system that gives the lowest possible numbers. With these rules, you can systematically name any haloarene compound. Thanks for watching.